Hi, my name is Justin, and this morning I'm joined with Rama, and we're going to spend some time talking about building offline applications with the Runtime SDKs. So, when you go to build an application or to add additional capabilities into your existing applications, there's a whole lot of different factors that affect the architecture of your solution and the user experience that you want to build for that solution. Now, these things, of course, change over time, and as the requirements of your project change, they need to grow as well. But there are a number of key things that you need to think about from the very beginning when you're building new solutions. And we think one of those things is the connectivity state of your application. Depending on how your application is going to be connected, it really can make a difference on the solution that you use and the architecture of your application. So there's a couple of different things we need to keep in mind when we think about connectivity state. One is your application going to be connected all of the time? And this is probably the easiest one. Thinking about maybe in an office or in a well-connected facility where you can guarantee that you always have a connection to the internet. And anytime that you don't have a connection to the internet or to your back-end database systems, you can kind of treat that as an error state, and work can basically stop until that connection comes back. On the other end of the spectrum, you have a disconnected application. So this could be anything from a remote field camp in the middle of the Arctic somewhere to just in the pockets of our own cities that just don't have very good coverage. And there's different considerations when we need to think about how we design the app to make sure that it's caching data or has the ability to have data preloaded. What's the life cycle of that data look like? How do we get updates for it? Does it need to be updated? Is that done when they come back into the office, or is it done over a somewhat spotty satellite connection out in the field? So all of these things really need to have an impact on the architecture of your solution. Now, the third one is where it starts to get a little bit more complicated in this occasionally connected state. So the runtime APIs do a little bit of ambient caching. We hold on to some features while you're panning around, some of your tiles from your base maps. But really, when we get and talk about architecting a solution, we really try and push this occasionally connected into one of the two other states. If it's really important that work needs to continue all the time with loss of connectivity, then treat the occasionally connected scenario as it's a disconnected case and have all of the data on your device. So, how many of you guys use the runtime APIs today? Show of hands. Cool. And about that, how many people are using Quartz or the 100 series of the runtime? Ooh, not as many. You got to get on the latest stuff. There's lots of cool things there. So regardless if you're using Quartz or the 10-2x generation of any of our runtime APIs, there's a lot of capabilities there. And a number of these capabilities work both in a connected and a disconnected state. And especially with the Quartz versions of the 100 series of the runtime, we've designed a lot of these to have very, very similar patterns, or the exact same pattern in a lot of cases, regardless of if it's disconnected or connected. So these capabilities include things like basics of viewing, editing your data, querying it, generating directions, finding locations in search, and doing some geoprocessing or other analytics with that data. So there's lots of capabilities in the runtime that work both online and offline. Now today, we're not necessarily going to cover all of those things. We only have 60 minutes this morning with you guys, and there's a lot of new stuff that we would like to look at as well. So this is kind of like my anti-agenda almost. This is a number of things that we're not going to talk about today. So what we are going to concentrate a lot on this morning is we're going to be talking about our new map-based workflows. If you've worked with offline capabilities in the runtime prior to 100.2, you were working with taking layers offline and then rebuilding your map yourself. But as of 100.2, we've introduced in new workflows that really make it easy to take a piece of your map offline and then work with it disconnected. And those are the workflows that we're really going to concentrate on this morning looking at. Now, all of that other stuff is still there. We still have the geodatabase sync task. We still have all of the options for working with your tile packages or or your geodatabases, all of that kind of layer-based activity is still there. And in fact, we continue to add more and more layers that work disconnected. In the 100 series of Runtime, we've added things like geo packages and shape files and ENC, which is a nautical charting format. And this capability to work with these disconnected data sets as layers continues to grow in the Runtime, and all of that's there. We're just not going to concentrate on it this morning. So as I said, what we're going to spend our time on is looking at maps and offline map workflows. So let's start a little bit with, well, what is a map? So the map really kind of is the basic part of the geo information model. It's really that one piece that kind of draws together all the components of the ArcGIS platform. It can be authored in one part of the platform and then used and consumed in all of the other ones. So you can make a web map you can make a map in Pro, and then you can consume that online in a viewer, maybe something made with JavaScript, or of course in your runtime applications. And as we all probably know already, maps are made up of a series of layers. And generally we talk about these layers as having a base map section, maybe raster or vector tiles generally, that provide some contextual information, and then a series of operational data that's usually on top of that. And these are things like our, excuse me, these are things like our additional data like our feature layers. And with our feature layers, we can have things like symbology and pop-ups. Again, these are things that we can author once inside of the platform and then have it leveraged across the whole of the platform and look very similar. So when you author that symbol once for a feature, it'll look the same no matter where you use it. So, and this power of authoring the map outside of the runtime makes it really nice for distribution models. So rather than having some of these things baked into code inside of your application, you can actually make tweaks to symbology in an online viewer and then restart your app, and you can have those changes reflected right there. So all of this relates to working with the platform information model, the ArcGIS platform information model. And underpinning all of this, we have data that's served out by services and then allows you to come up with a different set of layers. And we see a number of different things that we have there, from our feature layers, our tile layers, and then all of these things we use to author our maps. And then once we have these maps, they can be used inside of various parts of the platform. So supporting a number of the connectivity states that we talked about earlier, there's a few typical patterns that we talk about, a few typical workflows that we talk about for taking data offline or for working with maps. One of them, which we're not going to really spend any time on this morning at all, is the connected state. And the ArcGIS Runtime APIs have made it very easy to open up a web map that you've authored in another part of the platform and use that map. It's a couple of lines of code. Create the new map, assign it to your map view, and it comes to life, and you can work with it in a connected state. Now, the workflows that support working with offline, we kind of break those down into two categories. We talk about our services-based workflows, and those are the middle two we see on the list, the pre-planned and the on-demand, and then our fully disconnected state. So with the services-based patterns, on-demand and pre-planned, this is where your data has been served up in either ArcGIS Enterprise or ArcGIS Online, and then you go and you clip out a piece of that data, have it move down to your device where it can be worked with, and then you have the options to be able to either synchronize changes back up to the server and download changes that have happened from back-end things or from other users that have been out in the field. In the fully disconnected state, this is more of a read-only workflow. This is where you might not have any services at all. You might have applications that have never will be connected to the internet at all. This may be for security reasons or just because of the architecture of the rest of your system. And with the fully disconnected state, you can author data packages inside of ArcGIS Pro and then transfer those to your devices, side-loading them either through USB keys, walking them across air gaps, or through another distribution model on the web, and then leverage those packages inside of your applications. So as we said, there's a number of different data types that are supported for working with offline data and runtime. But when we talk about our services-based patterns, we're really kind of limiting that down to a smaller subset of that data. These are the things like our raster and vector tiles, our feature layers and tables, which are backed by our feature services inside of the platform, and feature collections, which is a block of JSON that can live as an item or as part of your web map inside of ArcGIS Online or your portal. So why it's limited to this set of data is because all of the data that you need to work with disconnected has to be enabled for this disconnected use. And that enabling for offline use comes in a variety of different ways depending on what data sources you're using and where that data is being hosted. So for a hosted feature service coming from ArcGIS Online, for example, on the settings page, there's a nice little button where you can go and say, enable synchronization. If you're working with ArcGIS Enterprise and your ArcGIS server, when you publish the service, there's a number of options there to be able to enable it for sync. And when you're working with enterprise data that lives in your enterprise geodatabase, there are a few considerations that you need to look at to be able to enable that data for sync in the first place. The pattern that we most recommend is using archive-enabled data, and then having global IDs, you can then enable sync for your data. So all of this is things that we've covered in past sessions and we have documented. But it's just important to know that you need to enable your offline data for use. Exact same thing happens with your raster and vector tiles. In both cases, either when you're publishing with Enterprise and you've turned on caching for rasters, there's an option to enable export tiles. And for your hosted services, when you go to your hosted tile service, you can see there's a nice little checkbox that says, again, allow offline mode. So with this, as I said, there's a number of different considerations for enabling your data for offline use. And we're not going to go into a lot of details with them, but one that I want to kind of highlight specifically is the version data workflow. Now, if you don't know anything about what version data is, good. It's okay, you don't need to, but we do know we have a lot of customers who still rely heavily on version data workflows. And these are supported with working offline inside of the runtime APIs. And when you create and set up your services based off of version data, you have to make a choice about whether or not you're going to have a version for each of the offline maps or a version for each of the users. And then one of the important things to note is that you need to have your own back-end process to reconcile and post all of those changes. So there's a little bit of additional work that you have to work with version data in terms of your back-end and reconciling everything. But if you don't know what any of that means, it's perfectly fine. Use non-version data or use hosted in the cloud data, and it makes things much easier. All right, so one of the things that we've introduced recently into the platform is something that we call the pre-planned workflows. So this is where we author a map and then are able to define specific areas as part of that map. And after those areas are defined, we then, in the back-end services, package that data up. So we go through the map, look at all the layers that are in the map, and then make the correct calls on the back end to the sync-enabled feature services or the export-enabled tile services. And we generate all of that data once and then stage that to be downloaded. And that can then be downloaded by multiple clients who are all going to be using the same area. And you can create multiple areas that work exactly the same way for the same map. So really what this is about doing is about optimizing the load on your back-end services. So if you think about that kind of traditional thing of maybe a workforce coming in at 9 a.m. in the morning on a Monday morning, and before the pre-planned workflows, they would all go hit the take offline button inside of your application. All of them would make individual requests back to your geodatabase, and that would have to scale to be able to account for that. Or they would all get queued, and it would take a much longer time because you were packaging and generating an individual package for every client that actually made a request for it. By leveraging a pre-planned workflow, you could schedule all of this to run the night before, on the weekend sometime, And when the client comes in and they hit the take offline button, they actually just go and download a series of items that have already been packaged for them. So there's no additional load on the GIS servers and on the back end. It's all just a download. So it happens much faster, and it also scales much, much better. Then after that, each of the clients still can do synchronization. So if it was, say, created 4 hours ago, we know there might be some changes that we want again, they can still do a sync afterwards. But this time, they're pulling down just a small delta of changes, not all of the data that's been specifically staged for them. So taking a look a little bit about what this actually looks like and where each of the pieces happen. So these are kind of the typical steps for getting data offline. We have somebody in the back office authoring a map and then setting up these map areas. And once they've authored these map areas, this then gets packaged by the back-end services. So this is built into Portal and online where this planning, this packaging of these areas happens. When your runtime clients come along, they're actually just starting it by doing a download. And then back in the still in the runtime, you can use that data just like any other way that you've got data in the system. View, query, edit, and synchronize if you're making changes with it. I think that's a good segue into a quick demo about how all of this works. So what we're going to do is we're going to start in ArcGIS Online, hopefully. We're going to start in ArcGIS Online. And we're going to take a look at one of the maps that I've authored and some new capabilities that just went live inside of ArcGIS Online to be able to author these web map areas. So this is on the item page for my map. And I've gone over to the settings page. And now on the settings page, we'll see there's a new offline section. Now some of these options in terms of enabling offline mode were there in the past. But the new piece that we'll see is this little section called Map Areas. And when I click the Map Areas, we'll get an experience now where I can add additional map areas and manage my map areas that are part of my project. So we'll start by, I have a couple of areas already there, but let's say we want to add in a new one. I click Create a New Area. I can draw that area. I could change its name. I can set the level of detail, the scale that I want to have packaged that my people in the field would be working with. And I can make some kind of determination about how often I want to have that data refreshed. So let's say I'd like to have the data refreshed every night at 10 p.m. So after everybody's come in from the field, and this is going to then stage all of the field changes for the next set of people who will go out the next day. And then I can create my map area. So what this is doing is it's capturing the data that we've just said, this extent, and it's now starting to go through the map and look at all of the layers that are in my map and starting to create packages for them. We can see we get our little notification here that it's working away and doing the packaging. And if we take a look at something that I packaged up this morning, we can see we have a list of what actually is included in this package, and we have some options for being able to refresh it for keeping it up to date. So we can see this map was actually made by a number of different services that actually came from, a number of different layers, that came from 2 different feature services, as well as included some raster tiles. So all of that data has been pre-packaged and is staged now for a client to come along and download it and use it. And with that, let's see what that looks like. So if we move over, so we move over now, we're taking a look at a runtime application that's been built with on 100.2.1.net. Now, all of this code we're going to look at today will be, well, at least my demos will all be in C# and .NET. But the objects, and when we start to go through the code and what we look at, will be very similar to all of the other runtime APIs that you're looking at. So those classes, the object, the methods that we have there will all have equivalency in Java or Swift or any of the APIs. It just happens to be we're going to look at it in .NET today. So here we have our map. It's not exactly the same map, but it's leveraging the same water inspection services that we have. And we can see we had 4 map areas authored for this map. And these have been staged and sit in the back end. And now we can choose to figure out, let's download Village Green Road area. And we select it, and we can download the area. And we'll see this is happening fairly quickly. It's going out, downloading those 2 geodatabases that we talked about, downloading the tile package, downloading the map and any overrides that we had for the symbology. So all of that stuff is coming down, and now the map is on our device, fully disconnected, and looks and feels the exact same way as if we were working in a connected state with it, or if we were working with it in ArcGIS Online. So I know, not a riveting demo at all, but the real exciting part about it is actually the code behind. If anybody's had to write this before, you're going to notice that this is a lot less code than what you would have had to put together. So we started off by using our new offline map task. And we created this offline map task with the map that we were using. We then went and asked it for all of the pre-planned areas that were associated with that map. And once we got those pre-planned areas, this is where we kind of populated that nice little sidebar we had. We can get some metadata about the extent that we had for those areas, the area of interest, so we can add the graphics that we had on the map, and then we can use its thumbnails and additional metadata to make a nice little tile. When we click download, we again used the offline map task, but this time we created our task, giving it the area we wanted to download and where we wanted to have that data stored on our device. Once that task was set up, we executed the job asynchronously, and when it completed successfully, we were able to just use that map inside of our application. So very few lines of code takes your map looking and feeling the exact same way as it did connected and sets it up for you to work offline. So one last thing. Hopefully, good. So one last thing we'll look at with the pre-planned areas is, so we saw a nice UI built into ArcGIS Online for creating these, but we know a lot of people are going to actually want to have back-end systems that don't need somebody to draw with a mouse and modify them and put them together. We know we're going to want to people are going to want to be able to automate this and build these with other systems being driven by scheduled tasks. So all of the capabilities for creating pre-planned areas have been built into the Python API. And here we can see just a very simple script where I was able to open up my map that I was using, and then I just used all of the bookmarks that were previously defined in the map, but this could just as easily be driven by another feature layer or some other thing that had extents with it. And then I was able to call create map area. And this kicked off all of that same back-end process to be able to stage that data. So the ArcGIS Python API is going to be a really nice way to be able to have automation of your creation for your pre-planned areas. Switching back over to our slides. Switching back over to our slides, we can just a quick recap on what we saw, some of the highlights of that. It was using the offline map task, getting our pre-planned areas, and then once we had our pre-planned area, using the download pre-planned area offline map task, executing that job, and then once the job had completed successfully, using that map inside of our application. So another complementary workflow to this is the on-demand workflow for taking data offline. So while we say the pre-planned one scales really well, we always know that in any field campaign, unexpected things are going to come up on a regular basis, and somebody's going to be somewhere and they're not going to be in the expected area, and they're going to need to take a chunk of data offline. If anybody's used Collector today, this is the workflow that we see built into Collector, where you have that nice experience of defining the area you want to use, and then hitting a button and watching it process all your data and taking that piece offline. So Collector right now is built on an on-demand workflow. So if we see, this is the same set of steps that we looked at in the offline workflow. And we still author our map just like we did. But the main difference now is in the kind of the middle part of this. So what happens now is the generation of that data is now driven by the runtime client itself. It's the thing that makes the request to actually go and have those sync-enabled geodatabases created and call export tiles. Processing and generation of those things still happen on the back end. The processing and generation of those things still happen on the back end, but it's done, as we said before, for every individual client, and then it's downloaded by the client as soon as they're ready and used just by them. But again, once the data is on the device, it can be used and consumed exactly the same way. So we'll switch back over to our app, and we'll take a look at our on-demand workflow. So we have the same map that we were using before, but this time we'll see we need to make a few more choices. There we go. That was odd. Thank you. Yeah, using Windows on top of a Mac in parallels with multiple things, sometimes somebody gets a little cranky. We're using the exact same map that we saw before, but now we see we have a number of choices that we can actually make. And you can either make these in code, or potentially the user makes these through one way or another. But the first thing we need to do is we need to figure out what area we're going to actually take offline. So we'll zoom to one specific area that we have here. We then can make choices like, do we want to take our attachments offline? Do we want to include the base maps? And what scale we want to work at. Going to knock it down a little bit. Once we've made these choices about what we want to actually bring offline, we can then generate our map area. So we're going to notice that this is actually going to take a little bit longer than what it did in the first demo. And that's because we've now gone to the server. We've asked the two feature services to make us a mobile geodatabase, and we've called export tiles on our base map layers. So now we have to kind of wait until those finish generating, and then we can download those. So it does take a little bit longer to do an ad hoc or the on-demand workflow, because it is being generated just for that individual client. Now, after, that really didn't work well, because I set the scale that we were working at so high, we zoomed out a little bit. But after the data was generated, it downloaded, and then we can see it. It's really there. All the data is offline. It's just really tiny in the middle of my screen. So we can switch over now, and we can take a look at the code that we needed to write to be able to work with an on-demand workflow. So the first thing that we needed to do is we just loaded up our map. So this is a kind of a difference. Before, we were using the offline map task and getting pre-planned. This, we just opened up our web map from an item and loaded it up into our map view. Once we had our map and we clicked the Take Offline button, this is where we went and we created our offline map task. So it's the same task, but this time we created a set of parameters that we wanted to use to actually take that data offline with. And this is where we were able to set the things like the scale, the base maps, and whether or not we were going to be using attachments. Once we had our parameters object set up, we then created our job, and executed asynchronously again. When it completed, we got a same map at the end that we were able to use inside of our application. So you see, actually a very similar pattern, and this task-based pattern is used pervasively across all of our runtime APIs in one way or another across many different functional areas. So it's something that you'll see come up quite a bit as you move into working with the 100 series of the runtime. So again, that quick little recap on what we just saw. Offline map task, create default parameters, potentially change some of those parameters, set your area of interest that you want to take offline, create a job, execute that job, use the result inside of your application. So now, once you have the data on your device, there are a number of different things that we can do with it. But one of the things that we see and we know people want to do a lot with is edit that data and then synchronize and push those changes back up to the server. So we've just taken a look in the last couple of slides about how we actually get that data on the device. Once that data is there, it doesn't matter if it came from an on-demand workflow or a pre-planned workflow. The data has been downloaded to the device, and then you can continue to work with it, make edits, changes to it. And once you're ready to, you can synchronize that data with the back-end services. And when you do that synchronization, there's a couple of different choices you can have about, do you want to just only upload your changes, or do you want to only download changes that have happened on the server side, or a bidirectional sync and move all the changes back and forward. So a little bit about how the sync process actually works. So we have our sync-enabled feature service, and we created our sync-enabled mobile geodatabase from that. Now, in the on-demand workflow, this was created by a request from the client. On the pre-planned workflow, this was created by a request from the back-end services. But regardless, you still have a mobile geodatabase that you're working with. And this mobile geodatabase gets transferred and is on the client device, where we then make edits, changes, modify our data. And then when we're ready, we call sync. This synchronization process first starts off by going through the data and creating a change set, creating that small delta of whatever changed on the device. So this would be feature attributes, the geometries, and any attachments that may have been modified for those features. Once that delta has been prepared, it's uploaded back to the service. The service does some processing of that, merges it into its back-end data stores, and then puts together a response. Now that response is dictated by the sync directions that you chose, and if there are any changes for your client to apply. So sometimes it's just as simple as an acknowledgement of, yep, I got your changes. To other times it may actually include another delta of changes that the client downloads and then applies to its local geodatabase. Now, at any stage of the game here, something can go wrong. We can have a failure to acknowledge some of the edits. We could have a failure to upload the changes. But the way that the sync process has been architected, both the client and the service always stay in a known state until there's multiple acknowledgements. So if, for example, we don't receive our response from the server, then that's okay. The next time we just think like, well, it didn't actually happen. And we do have to upload the changes again, but the server gets them and goes, oh, I already do know about these, and then sends the response again. So there's fault tolerance built into the system to make sure that everything always stays in a known state. So if you've worked with offline capabilities in the runtime today, you've probably worked with something called the geodatabase sync task. And this was the synchronization mechanism we had for working with and syncing layers. And it's still an important part of our workflows today. working with the geodatabase sync task, it targets working with a single service and gives you a lot of options and fine-grained control over how you want to synchronize individual layers, the direction you want to sync, and what kind of data you want to sync. And also being able to set different clauses on how much data you want to bring down for related tables or standalone tables that go along with it. So this is still a very important part of the synchronization process for getting that fine-grained control. But along with the offline map task, we did introduce an offline map sync task. And this was really about having that more simplified usage. So it's very simple to be able to call sync map, and it will go out and sync all of the different layers that you have inside of your map, pulling down changes potentially across multiple services, and just kind of making it work for you. But that does come with a simplified usage and more restricted options about what you can actually choose to sync. So we'll quickly switch over and have one more look at a little bit of code. So back in our pre-planned, this is where our pre-planned demo left off earlier, is we have our offline area downloaded, and now let's say we want to actually figure out and see, we know there are some changes that happened on the back end, and we want to go get the latest changes. So what we can do is we can just hit download changes. And this is going to go out, it's going to synchronize with the server, and it's going to pull down just the changes and only pull them down, not uploading any of the changes we would have made from the multiple geodatabases that were backing our map. And this is going to take a second to complete. While it does, we can switch over and take a look at the code for that. So in code, we can see that we created our offline map sync task with the map that we were using. We created our parameters and we set them, and the thing that we can set is our sync direction. So in this case, we would have set it to download only. And then once we had those parameters set up, we executed that job, created and executed that job, and then waited for it to complete successfully. Again, task-based pattern, very similar to what we saw for taking all of our data offline. Phew, it completed successfully. Nice. So very easy, without having to write a lot of code. It makes it really nice with the offline map sync task to be able to bring down changes and to keep your map in sync with what's going on in the back-end services. So with that, I'm going to turn it over to Rama to talk about working with fully disconnected maps.
Thanks, Justin. So we have seen the services pattern with both pre-planned and on-demand workflows. So now let's turn to the desktop pattern, where if you have an app where it needs to be working completely disconnected, where you are not even bothered to work with any of the services, then we have a solution for that. So you can create content through ArcGIS Desktop. It's for read-only workflows. The data that we author in the desktop is completely, you cannot edit them, as you just consume it in your client. The data is packaged as mobile map packages, which can include your locators, network data sets as part of your mobile map package. And mostly the mobile map package has to be side-loaded into your device, or you can host it on an web server and download it whenever you need, or even you can use ArcGIS Online as well for that. One good offering we have is StreetMap Premium Data for ArcGIS, which also packages data as mobile map packages, which includes really a good base map of streets, and it includes locator as well as network data sets. So with that, let's see a demo in Android with an example app.
So actually that StreetMap Premium for ArcGIS data is the data that powers the Navigator application as well. So it's something that we've made available through our apps, but also you can leverage inside of your own apps by using the StreetMap Premium. Sorry, wrong.
Yeah, no problem. So let's see an example app. Example apps are something that we started rolling out from more than a year now, like where we kind of give a workflow to the app, and it's completely open source. It's available in GitHub. You can download and use as a starting point for customizing your apps. Let's see the offline map book for Android. The important part of this is the data preparation. We use ArcGIS Desktop, particularly the Pro. So here is a scenario where there's a water company where the field worker needs multiple maps to work with. So for example, in this case, they want an 811 map for locating the water mains and lines, and an emergency response map so that they can know how their mains and valves are associated. Mains and valves are for an emergency leak based on the size of it. And there is also a map for to know what are the new water lines that are coming up in that project. So the field worker wants these multiple maps packaged and available for them to work in a fully disconnected mode. So we can choose how each map is defined. We can choose the layers for each map. We can choose the symbology defined based on one map can have a pipe symbology defined based on the pipe material. The other one can be based on a pipe diameter or valve type. So we can choose individual types. They also need an ability to search those mains and lines, so they can. So they want an locator to be included, and they want some bookmarks to quickly access or navigate to certain places. So we can choose all these things and order them in a desktop using a Create Mobile Map Package tool, GP tool. We can open the map, choose all the symbology, all the layers, and then just include them as an input to this GP tool. And then when you run that GP tool, your fully disconnected mobile map package is ready. And now you can go back to your, the field worker can go back to the device that they have, and they can open the same mobile map package, which is either sideloaded or downloaded from whatever web server that is hosted. They can go and open those maps. They can see the same style that is defined on the desktop. So in this case, you can see the operational layers that are symbolized based on the material type. You could see the bookmarks are available. So somebody that are authored in the desktop, they are available in the mobile device as well. And you have the search capability. You can search by an address, or like if you want to search by an water main, you can choose that as well. You can switch between the multiple maps that are available in the mobile map package. For example, you can open the proposed map as well. So you can go to the bookmark, which is the new proposed water mains or lines. So they can quickly see those in the field. Similarly, there is an emergency response map. This one, which was symbolized based on the size of the diameter of the valves and the water mains. So you can see that it is also available. So that gives the complete control of working completely disconnected, where you author the data once in desktop, and then you just take it to your device and give it to any number of field workers, and they can work on that. With that, I'll switch back to Justin.
Hold on. There you go.
Okay.
Come on. There we go. All right. So So we saw a quick demo from Rama about how you can work with completely disconnected data. And there's a number of scenarios where this does make sense about having data that needs to be secure or potentially not coming from services-based data sources. And that consolidation that happens inside of Pro can allow you to leverage a lot of different data types inside of your runtime applications. So this morning we looked at a number of different things. How to build offline applications with the runtime and some of the considerations for moving data around and getting it to your device. The pre-planned workflow, which was new at the 100.2 series of the runtime, really added a complementary piece into the offline story. We still have our ad hoc capabilities, which are great for when you don't necessarily know exactly where your field users are going to have to go, or they need to have unplanned things and have to generate that data and use it right away. But the pre-planned workflow is really a nice optimization to be able to offload the pressure on your geodatabases and your back-end services to more planned times during off-peak hours. So it's really something that we encourage you to take a look at for your workflows of moving data offline. And we're continuing to make enhancements in this area. One of the things that we're working with as a platform is also being able to generate those change sets to be able to have them downloaded by multiple clients as well. So we're working on an optimized ability to get changes from the server. We saw in the demo earlier that I had to still synchronize my data. I still went back and got from the client a specific set of changes just for that client. But with new work that we're doing inside of the platform, what we'll do is on the back end, we'll regularly generate all of those change sets, and as a client, you just come in and download them. So again, continuing to optimize how you can get read-only data on your device in this case. For edits, you always have to have your own sets and push them back up. But we're continuing to put a lot of effort into optimizing moving data offline. And we'll see this in the runtime applications, but it'll also be leveraged in other parts of the platform, like inside of Collector and Explorer. So with building applications on top of the 100 series of runtime, really think about trying to leverage the WebGIS patterns. It really does bring a lot of versatility in terms of how you can leverage the whole platform. Authoring maps in one place and using them in many, not having symbology hard-coded inside of your application. So if somebody wants to now have a red-colored valve rather than a blue-colored valve, you don't actually have to redeploy your app. Somebody can make those changes in the web map or inside of Pro and have those changes reflected inside of your application. So really by leveraging the WebGIS pattern and by leveraging the ArcGIS information model, it can make app deployment simpler in a lot of cases. And finally, take connectivity into account from the ground up when you're architecting your solutions. If you have any ability, of course things always change. Somebody will always come along with the requirement later of, oh, I wish it worked offline now. But thinking about that stuff from the ground up really allows you to architect the best solution. And then finally, of course, all of these things are mix and match. So sometimes you will have to have a connected application that also works disconnected and works with data that is sometimes connected and other times not. All of these things work together. And the nice thing about the new versions of the runtime is that no matter what you're working with for feature data specifically and other offline, online capabilities, the patterns are the same tasks for working with them, the same base classes. So with our features, you can work with a feature table, or you can work with the specializations of a geodatabase feature table or a service feature table. But if you work with the base classes and work against those, you're able to author tools that work both online and offline. So finally, and I pasted in both of the same screenshot, but all of the source code that we looked at is available for both the applications that we looked at today right now on GitHub. I can change it and show you where the other one actually lives afterwards. But as Rama said, the source code for the offline mapbook app is living in our Esri repo with our example apps, and the whole documentation, everything we saw for it was there. All the source code for the The .NET app that I was looking at today is available in a branch in one of our demo repos on GitHub as well, and I can put that link up here in a second. But all of this you can go grab right now, and you can work with it immediately. It's built off of the 100.2.1 series of the runtime. We just had a release, 100.3, on Thursday of last week, and I know I didn't get a chance to update my stuff right before the conference, but you can build it against that as well. So all the code's available to you today. You can grab it and start playing with it right away. And with that, please download the survey app or the events app if you haven't already been using it all week long, and please rate our app. Your feedback for these sessions is invaluable. It helps us figure out what we're going to show next time and where we can make improvements to make sure we're delivering the right content in the right way. So feedback is really appreciated for sure. Thank you very much for coming this morning, and we've got time. We can take some questions. Yeah.
Question is kind of related more just generally about the runtime, SDK, other format support. So
yeah.
Can you build a geo package in ArcGIS Pro and that into your runtime application?
So the question is about specifically about geo packages and using them inside of the runtime. And yes, the answer, you can do that. You can author a geo package either in ArcGIS Pro or any of the other open source tools or other tools out there, and then you can consume that geo package inside of the runtime application. Yep. I think we'll hear, yeah.
Sorry for my poor English. Okay. I understand that the instruction I see generate an MMPK file. That's correct?
Okay.
Okay. And in this file, there is the cache files, the file cache. That's all I have on the future layers, on the layer. It's omnicomprehensive.
So the question is about the structure of our mobile map packages, or the MMPKs, and what's inside of them. So the mobile map packages is what gets created from the GP tool that Rama had shown inside of ArcGIS Pro. And inside of that, there is a number of different things that there. There is the mobile geodatabases, which would contain your features, but depending on, that's as long as there was feature data, I guess. And then there also is potentially tile packages for any raster tiles that you had there. There may be locators that have been enabled for runtime, and parts of the data set for doing routing as well. And
I set what I want.
Pardon?
Via code, I set what I want.
To you, yeah. So yeah, once you have your mobile map package authored, you then, inside of code, are able to, do you have that snippet? Inside of code, you're able to open up that mobile map package. You can interrogate its contents, so it'll tell you what maps are there, it'll tell you what networks and locators are there, and then with that list of things that are contained in the package, you can then use them inside of your application. Yeah, and that's all included in that code that Rama would have shown, and is all available in that mobile map package demo, and that offline mapbook app would have all of those things in it and show you how to make that work.
And if I don't have a network, I can pass
Yep.
Android to be out.
Yep. This is so the question is, once you have that mobile map package, how do you get it on your device? And that needs to be side loaded. One of the ways to side load it is you could stick it on a USB key and walk it over to the other machine, put it in. It's fully disconnected. It doesn't ever have to be connected to the internet at all. Yeah. Yes.
Somewhat related to that, but I think you guys mentioned this, and I just want to confirm it. So if you do all your configuration of the pop-ups within ArcPro and then create the mobile map package there, and you don't want to change anything, so is there any code on the other end when you're writing the application, or does it?
So it'll
have to go through and code how you want the pop-ups?
Nope, it'll leverage the pop-up. Yep.
My other question is related. It's now you now support vector tiles. So when you create that mobile map package, and on my situation, we use our vector tile layers for our base map service. So is it able to take that?
Yes.
That and carry it over?
Yep.
Okay.
So it can take any vector tile or raster tile layer.
Okay,
Yeah.
cool.
Yeah, so the question was first about pop-ups, and if you author pop-ups in one place in the platform, can you use it inside a runtime without rewriting it? The answer is yes. It doesn't matter if it's connected, disconnected, on-demand, pre-planned, all of that kind of stuff. That's one of the powers of actually leveraging the platform is author that pop-up once, have similarly looking across the whole. Yeah, and then the next follow-on question was about the vector tiles and using those. And yes, the Esri base maps do support export tiles and can be used offline. So,
And is the example, was that in Java or was it in C# for the mobile, for the offline one?
The one that's Android, so it's Java.
Java. Okay.
Yeah.
any more? Yep.
Yeah, for the create map areas, are the APIs available to create those off of Portal Web Maps, or is it just ArcGIS Online right now?
Yeah, so the question is about the create map, the pre-planned areas and where we can use that right now. So it's available both in enterprise and in online right now. Now, the one thing I don't know, we can actually go find the answer afterwards, is the UI that we looked at for creating it, I believe that might actually only be in online right now, but the back-end pieces where you could use like the Python API, that is on enterprise. So you can still create and work with it there.
Follow up on that, is there a limit to the number of map areas you can create against a single?
Ooh. And the question is if there's a limit to the number of map areas. I think there is. I believe it's 16. Yeah, so we did make a choice to limit the number of them, and I'm pretty sure it's at 16. That's something we can be interested to hear if you have more map areas and what your use case is afterwards for having more of those, because we decided we needed to have some kind of limit, just like we did with exporting tiles. We decided there's a limit to the size of what these should be, and we want to adjust them over time to make sure that they're meeting the most use cases as possible, but not potentially putting undue burden on back-end services. So definitely something we could talk about.
Just to follow up on that one, can the map areas be a regular shape so they have to be?
Another great question about what extents or polygons can drive map areas. Right now, they're extent-based. So it is not, they cannot be a regular shape. That is definitely on our list to do. We know, especially for pipelines or, transmission lines, anything like that, linear features where you need to buffer them, having to do an extent, unless it just runs perfectly north-south or east-west, it's going to be a lot more data. So it's definitely something on that we want and know we need to support. Yeah. I think you had a question. Oh, okay. Yes.
So comparing the different models that you presented, one would be the pre-plan where I'm going to extend the area that I'm interested,
Yep.
versus on-demand. And I want to add to the on-demand with synchronization. So the first time around, it's, let's say, the whole area. But after that, on the days that follows, I really want to get only the delta, so I want to do synchronization, and I'm not doing any editing of the features on my talent. Which one do you recommend? Which one is more appropriate?
So the question is about pre-plan versus on-demand and follow-up synchronization after that. Actually, it makes no difference. It's exactly the same. In the pre-plan, right now, the pre-planned and on-demand, once that data is downloaded the first time, after that, you're using the exact same synchronization mechanism. So at this point in time, it actually doesn't make any difference at all. You still have that mobile geodatabase on your device after either getting it on-demand or from one of the pre-planned areas, and then you still call synchronization the same way, and it still goes off, and per individual client, it requests those set of changes. Now, going forward, that's actually going to change. We're going to be adding in a optimized way to be able to get read-only data coming down from the server that's already been pre-staged and can be used by multiple clients. So instead of actually getting a custom change set per client, you'll be able to just go get one change set that related to that pre-planned area that you downloaded, and hundreds or thousands of clients could all apply them. But that's not there yet. That's something that we're targeting for the next couple releases in the platform. So right now, it doesn't matter. Both of them will just bring down the changes, and you just do a one-way download-only sync.
So I have two choices here with the pre-plan. One is to press the sync button and have the geodatabase
Yep.
Now, if I have 100 users in the morning at 8 a.m., all pressing the sync button at the same time, that's
Yes.
one. The other choice is that I can go republish the area and have them basically,
Download. Yep.
Which one is the...
So that is a much more than a 2-second answer. So what I'm going to do is say thank you very much for all coming. We can talk immediately right now, and we can talk about that. Anybody else who has questions definitely will be around. I'm just going to wrap it up because we know there's going to be more stuff coming in. Thank you all for coming this morning. Have a good rest of your conference.
Thank you.